Welcome to qnawire.
So here for part A, since the units of A times the units of T must equal meters, so we have A times T, this means that A times T must equal a unit of meters. So this means that we know that T is measured in seconds, therefore A must be meters per second multiplied by seconds in order to equal meters. Therefore, units of A should equal meters per second. For B, we know that B must equal meters, which means that this is going to be meters per second squared multiplied by seconds squared, which means that the units of B must equal meters per second squared. For part B, they want us to find the acceleration. So the acceleration is going to be the second derivative of the position function. We excuse me. We know that for part B, the position function equals AT plus BT squared. And so the velocity would be equal to the first derivative. This would be A plus 2BT. And then for the acceleration, this is going to equal the derivative of the velocity function with respect to time. This would be equal to the second derivative of the position function, again, with respect to time. And this would be equal to simply 2 times B. The units here would be meters per second squared. Now for part C, let's get a new workbook. For part C, they want us to find the velocity at 5 seconds. So we can say that V equals A plus 2 times BT, which means that the velocity at 5 seconds would be equal to A plus 2 times 5 times B. So this would be equal to A plus 10B. Units here would be meters per second. And then the acceleration would be constant at 2B. And the units here would be meters per second squared. And finally, for part D, they want us to find the velocity function. We know the position function is AT plus BT to the negative third power. Therefore, the velocity function will be the first derivative of the position function. So this would be equal to A minus 3B times T to the negative fourth power. That is the end of the solution. Thank you for watching.